Welcome. It has just gone 7 p.m, the 16th of March, and you are watching Regional Wrap, episode 40. Regional Wrap, providing an insight to the issues affecting regional Australia and giving the voice to regional residents. My name is Bill Bates, and returning for part 2 on all things nuclear, future developments in the nuclear industry, is my guest, Dr. Mark Ho. Mark is the Vice President of the Australian Nuclear Association, an independent scientific organisation representing the members of the profession, enthusiasts, and engaging with government, industry and the community on all things nuclear. In his day job, Mark works at Australia's Nuclear Science and Technology Organisation, which operates Australia's only reactor at Lucas Heights, New South Wales. Welcome again, Mark.
Thanks for having me, Bill.
Well, if we can just start off just recapping on the nuclear industry as it stands today and what people generally envisage when you start talking about it before we move on in regards to innovations that are coming forward in the next 10, 20 years or so.
Okay.
With that in mind, I'd just like to flip up the photo of a nuclear power station, and this is basically what I think what most people would have in their mind when you talk about nuclear power. This is the new power station, or 2 reactors being built in Georgia, United States. And this is the sort of outlook most people think of when they envisage a nuclear power station. But one of the big things with these and this generation of nuclear reactors is the time it takes to build these days and the cost. And the overruns on these 2 reactors has sort of pushed the price up to $30 billion US dollars and several years delay. So as we move forward, what will we be looking at, do you think?
Okay. So, I mean, to take what you were saying, if I could just kind of reestablish where we were from last time, just give an overall picture of what nuclear power looks like around the world. As a lot of people might know, nuclear power powers 10% of the world's electricity grids. It doesn't emit any CO2, so it's base load, it's reliable, and there are about 440 odd nuclear power reactors around the world, 300 of which are what they call the pressurized water reactor variety. That's the mainstay or the backbone of the nuclear power fleet. And so what you were showing, which is the newer, what they call generation 3+ pressurized water reactors, one of them, those designs being the AP1000 from Westinghouse. Yes, they have suffered from some delays because, as I was saying, the US took a long time getting back into the nuclear build game. And so therefore, they've had troubles, getting the proper suppliers and fabricators and everyone in line. So looking into the future, the immediate short-term looking at innovations in nuclear power, we'll probably be seeing the small modular reactors coming off the assembly line once it's been established. So one of those designs is called NuScale, a NuScale reactor. One of those modules is only 77 megawatts, but the way that they deploy them is usually in banks of 12 or banks of 6, kind of like a dozen eggs, so to speak, but a dozen reactors. And then instead of having these very, very large kind of structures, what you were showing with what they call the containment vessel to contain any kind of radioactivity that might come out in case there's an accident, these reactors are very different. They're much smaller, they're much more modular. And instead of putting these large containment structures around them, they're actually all put into a massive common swimming pool, pretty much. This large common pool, the idea is to use that water to keep those reactor cools after you shut down. So you don't have cases where you've got like Fukushima where you got a station blackout and you aren't able to take that very, very small 1% amount of residual heat away after you shut those reactors down. So those smaller NuScale reactors are also the pressurized water reactor variety. So they're using all the kind of learned lessons, all the technical acumen and the know-how that they've been built up in the last 50 years and applying it to a much more compact design. But not too far off in the future, because those NuScale reactors, we're probably going to be seeing the first of a kind switched on by 2028, 29. And the newer ones, which are just going to be a couple of years after, could be very, very exotic, meaning unfamiliar to most people. Using water is not the only way to cool a reactor. In fact, at the very beginning of the nuclear age, nuclear scientists thought of all kinds of ways to cool reactors and to put assemblies, reactor cores together. So you could do stuff like cool the core with liquid sodium. Sodium, which is usually a metal at room temperature, becomes a liquid when you raise the temperature up to, say, 400 odd degrees. Or you can use such things as molten salt. So, the salt that we take, table salt, if you add some other elements, you could make a different type of chloride salt. And if you melt that salt is actually an incredibly good carrier of heat volumetrically. So like by the same volume for volume, it's comparable to water in being able to take heat away from the reactor. And
and also used in renewables in the solar systems too, aren't they? Like
exactly.
And that.
So they're called solar salts.
Yeah, actually in use now.
Yeah, so they're a cheaper kind of like a mixture of nitrate salts, I think. But when we're talking about molten salt, for a reactor, it's actually very different because you want to take those. You basically choose the type of salt for the type of reactor you want to build. So, for example, one of the things that the Americans had done back in the 50s and 60s was to set up a molten salt reactor experiment, which could be turned on to a power of about 8 megawatts. And it was completely air cooled, which was the brilliant thing about molten salt. And it didn't need to be pressurized because salt has what they call very low vapor pressure, meaning that it doesn't need pressurization to prevent it from boiling. It stays liquid up to like 1400 degrees C. And the other brilliant thing about, having salt as your heat media, like a heat carrier, as well as the transport or the body of mass that you actually put your fuel in, is you can even dissolve your uranium fuel directly in the primary salt itself so that there aren't any structures in your reactor core region. I mean, it's really, really incredibly, amazingly high-tech stuff. And in fact, these are the type of designs that are being contemplated as the next generation of advanced reactors that's currently under research and under development.
Is this a coordinated effort between countries, or is there a number of parties going each in their own way and in sort of competition that sort of probably give us the best product?
Yeah, so it's actually a bit of both. So, I mean, as you audience might have heard, there's a large international body called the International Atomic Energy Agency, which is the IAEA, and they run a lot of what they call cooperative research projects, okay? And some of these research projects might focus on a particularly exotic reactor or advanced reactor. So in the past, for example, even though, we had the Cold War and everything, but in fact, a lot of leading nations, the US, the UK, Russia, France, they actually all cooperated into looking at something called, sodium cooled fast reactors, or sodium metal cooled liquid, that is, fast neutron reactors, because these reactors could do a variety of things like breed fuel or destroy nuclear waste. And they knew that there weren't that many centers of excellences, and there's only a finite amount of national lab staff to work on this stuff, and it made much more sense for all these countries to actually work together and to swap nodes, so to speak, and to come up with like an optimized and a safe sodium fast reactor design. Okay. And there are other designs as well, such as the molten salt reactor, which is a combination of both an international cooperation as well as private industry kind of undertaking. For example, TerraPower.
With the direction you're talking about, does that mean we're going to skip over things that we've heard of in the last 10 years, like forum reactors, pebble reactors, and those sort of things that were discussed? We got to leap over them, or are they going to be in the mix too?
So yeah, they're actually all in the mix. I mean, we have to kind of somewhat, I think about how we're going to structure this discussion tonight, just because okay, maybe I can give you a kind of broad arching framework. So Australia is actually a participant in what they call the Generation 4 Reactor Forum, okay? And this forum is for countries to share knowledge and information on some of the research and development they've been doing for advanced reactors. Now, there are a number of advanced reactors. The whole reason for actually having what they call a Gen 4 forum is that, essentially as countries are just trying to build a better reactor, ones which are intrinsically safe, that won't melt down, ones which are more economically to run, ones which could burn nuclear waste, for instance, the kind of long-lived nuclear waste. You can just use the excess neutrons to burn or to consume those elements. But of course, it's hard to attain the ideal, and that's why, in fact, the Gen 4 Forum looks into a number of different reactor designs, each of which are very good at one particular thing. And for Australia, what we've signed on to do is actually to look at two advanced reactor types in particular. One is what they call the high temperature gas reactor, cooled by helium. We're using pebble bed fuel. And the other being a molten salt reactor, which could be either powered by solid pebble fuel or with the uranium tetrafluoride fuel dissolved in the salt itself. And the reasons why we're doing that is because Australia is a mining country, and we still want to maintain a high level of industrialization. And so if we can have a low carbon source of baseload heat and electricity, we can use that high temperature to power our heavy industries. And that's why we're kind of keeping abreast with those developments.
You're talking about like smelters, like aluminium smelters and steel furnaces.
Yeah, I think even concrete making takes a lot of heat, or any kind of very heavy industries takes a lot of heat. I think so. For example, if you look across the ocean and you look at Canada, they've got a large nuclear power station called Bruce over in Ontario, I believe. And they use a lot of that electricity, and it's co-located with a lot of their kind of industrial plants. And of course, they don't have the high temperatures like advanced reactors, but actually use a lot of even the waste heat and, the electricity from those very close nuclear power plants to power the industry.
I think France also used their secondary heat and that for general heating of whole townships, and that's near the reactors as well. They actually pump the hot water through the city so they can utilise that.
Oh yeah, I mean, any country with very, very cold climates just absolutely love nuclear power.
Well, France has been one to jump on the bandwagon very early in the piece, and I think it still gets 70% of its power from nuclear.
Yeah.
In regards to deployment, and like you said, you were looking at sort of a number of modules in one location, basically replacing a large power station in the gigawatts region. Do they also lend themselves to sort of deployment along the grid to connect into the grid at various places? So because we do know there's transmission losses, and the other thing is there's a lot of fluctuation in the grid between peak hours and things like that. Would they lend themselves to that sort of application, or do you think it's only ever going to be co-located, a number of them co-located in one spot?
Yeah, so what you described there is what the industry terms as being ancillary services. So at the moment, I mean, the need to kind of like put inertia onto the grid or put stability on the grid isn't really valued that as much, but it will be valued much more when there are more intermittent kind of sources like wind and solar on the grid. And in fact, over in the US, SMRs like SMR vendors like NewScale or like BWRX, they know that they actually market their SMRs as being these very, very reliable power stations that have the capability to actually restart the grid itself, what they call like black start or something, along those lines. And I think, they're actually going to be kind of like centers of like security. Another use for SMRs as well is that they're kind of thought of as being very reliable power sources. So, for example, if you've got a piece of infrastructure or a military base that cannot ever have uninterrupted power, you might consider powering those facilities with a nuclear reactor or an SMR.
In regards to that application, but you would hope, but if we go down the path of embracing nuclear, and I don't know about you, have you found it surprising since the conversation with the submarines and the acceptance of the nuclear submarines, there's no real hint on the horizon either from any group or even the public about being frightened or adverse to the advancement of nuclear power in Australia? Are you surprised?
I actually not too surprised. The reason why I say that is because, Australians are actually warming up to the idea of nuclear power, and that's been coming for a while now because, just monitoring, the poll numbers and just even before the announcement of AUKUS, there were numbers showing that people are basically 50-50 for and against nuclear power almost, which is actually quite good because if you look at some other nuclear nations which already have nuclear power, the numbers are about the same. A lot of people are always going to be for and against. So in terms of nuclear power, people are already are kind of on the back of their minds. They kind of know, there's all these noises and voices saying that we need to reduce carbon. But then they also, people want to have reliable power and they don't really know how we could do that unless you have a base load dispatchable source of low carbon electricity, and I think as well, with the AUKUS announcement, as the rapidly deteriorating security situation in Europe and, in our backyard as well, some might say, people are going to think, well, maybe we actually need an insurance policy in the form of nuclear powered submarines. And in terms of a level of risk, we don't see it as that high compared to the risk of our current situation. I think that's very important to understand.
One of the other things too is, I suppose that to get over that 50-50 type of thing and get it more into the positive arena, the idea of safer reactors, smaller modular reactors, and that will probably help a lot allay any sort of fears and sort of resistance going in the future as well.
Yeah, I think that's very true. Yeah, I think it's very true. The SMRs, they look very, very different from the large reactors that you just showed. They're below ground. They're basically all situated underneath a big swimming pool, the ones that I was talking about. And, in a kind of visual comparison, in fact, our own, Opal research reactor sits under a massive swimming pool as well, underneath about 10 meters of water. And, for those that do diving, they know, that having a lot of water above you basically forestalls the boiling point from 100 to 120 degrees. This is the kind of intrinsic safety that we're talking about, right? So if you look at our very safe research reactor, and then you look at, this, say, NewScale SMR next to it, which is of course larger, but it's also underneath a huge body of water. And then you just basically tell them, look, the idea of having that huge body of water is just to make sure that that reactor remains cool and can't melt down. And people will go, oh, okay, is that all that is? You know?
I think one of the other thing about the big reactors, I mean, they have similar problems as coal-fired plants, ramping up and ramping down, sort of depending on the load. So would the modular reactors sort of counter that in a fair manner, in a fair degree?
Yes.
Being able to bring what's online fairly quickly to deal with that power adjustment, like at 6 o'clock at night when everyone comes home and turns the stove on and all the electricity. We need a big boost, and coal-fired stations take time to ramp up, and that's where, you know, gas turbines come into play and are very helpful in conjunction with coal-fired power stations. Nuclear power stations have that. The large ones have that similar problem. And do you see this as a real advantage going forward, that we can deal with those peaks and troughs in the supply?
Yeah, it absolutely, because the reactor designers now, they know that they're living in the now and into the future, and they know that they're going to have to deal with the challenge of having lots of renewables on the grid. And so, in fact, NuScale, for example, carried out a study where they just wanted to see if one small module could actually load follow the very fast changes in electricity output from a wind farm, for instance. You know, this 57 megawatt wind farm, which fluctuated quite largely, and they just wanted to see whether that reactor could actually take the load, for instance, when the wind died. And it could. And there are a number of techniques that those reactors can do that at. You know, you can raise power by moving the control rods, or you can do such things, what they call like a steam bypass run. So say if you want to dump power very quickly, then you can just like do a steam bypass job and just dump all that power without having to shut down. So, you know, those are actually just for the pressurized water reactors, but when we're looking into the future, a lot of the advanced reactors operate at a much higher temperature. So we're talking about maybe 600 to like 800 degrees C, okay? And with those reactors, what's interesting is that they actually they can store a lot of that power in the form of a heat bank, like a large vat of salt. And the idea is that you can extract that power at will when you want, but without actually having to ramp the reactor that hard anyway, because the reactor is just churning away and dumping heat into the heat bank. And then at the same time, you might have a Brayton cycle or a gas turbine taking that heat out as kind of like a peaking plant, operating as a peaking plant.
But going forward, why would we want nuclear power if we can get into these small reactors? Why would we want it to play second fiddle to intermittent power that has a huge footprint? Like ecologically, the footprint of renewables compared to the footprint of per megawatt is, you know, so huge. Like just a wind farm, like what the biggest wind farm we've got in Queensland is only got a nameplate of about 500 at the moment, 570 megawatts. But as baseload power, that only equates to, even if it had full backup, would only equate to about less than 200 megawatts. So to get to a gigawatt of baseload power, you need about 9 or 10 Cooper's Gap's wind farm of 102 square kilometres. And then you've got all the connections, like the copper between the turbines to get to the substation. And then the production footprint as well. Why would we want to run two systems at once?
I'm really glad that you should bring that up, and I'm really glad that you're such a big fan of nuclear power. I mean, I talk about these things all the time, and people just don't realize just how compact and how reliable, you know, and how powerful these reactors are. But, you know, the short answer is that, look, I mean, the nuclear industry plays nice. It's not us that's saying we don't need renewables. It's the renewables lobby that says we don't need nuclear power, right? But of course they'll say that. So what can I
Well, that's
say?
one of the things that really concerns me. You've got all these people in the climate change lobby, you know, basically poo-pooing plant food, and that's what carbon dioxide is. I don't care what anyone says, it's plant food, and it's greening our planet. But if it's so imperative, we've got to get rid of, get CO2 down, nuclear wins hands down, because the amount of the footprint or carbon footprint to even manufacture and put in place the utility that's going to deliver a gigawatt is a fraction of the mining, processing, manufacturing, and installation of and footprint of these renewables. So I just don't understand. If you are really that concerned about CO2 emissions, you have to look at nuclear, but these people just don't seem to want it.
Well, it's hard to change people's views, especially if they're very established. What can I say? I mean, I like to deal with facts, and I just keep it at the facts.
I suppose one of the things that might change mind is the dollar cost is in regards to what you have to pay for electricity to ensure, well, for base load 24/7 electricity. And I think that's probably going to be the telling factor moving forward.
Yeah, that's very true. But I mean, to be a little bit cheeky, you can kind of say that the price of nuclear power in Australia at the moment is at an infinity, because we have federal and state bans on nuclear power, right? So even if you build it, you're not able to be licensed it, and so therefore the cost of nuclear power is infinite. But that's just, market barriers.
I suppose it'd be interesting to see how long it does take to change the, I think it's the 1999 Environmental Act that sort of put the ban in place. And like I say, it's not a big deal to remove it. It's just passing an act in Parliament. It doesn't need a referendum. It doesn't need anything. And if you've got a majority government in both houses, it's just a stroke of a pen and it's gone. So,
well, I mean, I'd like to think it's that easy too, but if you've been in the game as long as I have, you kind of know that building reactors is a multi-election cycle exercise, and so therefore you really want to get that bipartisan support to remove the ban, and not only to just remove the ban, but also to do it well, for the government to be involved, and so that they can make sure that everything's done right, and the community can be assured that everything's done well. So yeah, I know that, for example, not to blow any kind of political private party's trumpet, and I won't name them, but some political parties have been talking to the ANA and say, look, we agree with you, and we back it, as our political party, a mandate or edict or outlook.
Yeah. One of the other things, though, if we do go forward with nuclear and that, if it's going to be investors' money, and private enterprise, if they've got to deal with this situation where they're only paying fill-in for wind and sun, why would they bother? Because to be a commercial operation, you've got to have a guaranteed income. You build a facility that can deliver 1.4 gigawatts of power 24/7, even with maintenance downtime, because that's how they design them, with enough spare turbines and stuff like that. If you have to switch off when the sun's shot, every time the sun pops out or the wind blows hard, and you've got to cut down your output to let them pick up their revenue, well, how are you going to? Look, I find it very difficult to see what incentive is.
That's actually a very astute question to ask, and I asked the same question too, because currently, if you look at the way the grid operates, is that any kind of dispatchable source, any kind of solar or wind intermittent sources, they have priority of dispatch, right? They just dispatch when they please, and so what it is that the cost of actually being able to supply power at will is externalized to those thermal generation units like gas or coal-fired power plants. So it's actually quite unfair in a way, But but to answer your question straight, the way that future nuclear is going to address this problem is basically design a reactor that is much more streamlined, much more inherently safe, and much more simplified, so that you could do things like supply power at 30 cents per kilowatt hour or less, so that they can directly compete and win against gas. Because a lot of the advanced reactors which are under development in the US, they know that fracked gas is cheap, and so therefore they must come up with a design that can economically compete against gas itself. And when they do that, that will be the real game changer.
Yeah, like I say, I mean, I still have problems with anyone coming forward to put in investment where they're going to be hamstrung. I mean, I think the playing field would have to be dealt with long before they actually put a shovel in the ground.
Yeah, but I think that's an electricity market question, very much so.
Well, that's got to be the main role for it, and so that's the item that's got to pay the bills and make the profit for the investors. So, like I say, that needs to be really sorted out long time before we get to the stage of building.
I do think that there should be. I mean, we are looking at more and more kind of like government involvement with a lot of these questions as to how are we going to increase the amount of generation on the grid, and how are we going to make sure that the industry is supplied with sufficiently cheap power. Because from what I hear from other people in the game or in the industry is that the problem as well is just being able to gather up enough of these kind of power purchasing agreements before you can go to the financier and go, hey, I got all these agreements. These industries and utilities are happy to take them out this amount of power for this new power plant that I'm about to build, right? I mean, even that in itself is difficult currently, because no one really knows what the future electricity market's going to look like, and no one really knows whether they're going to be in business like in 5-10 years time. So how are you going to, so it's kind of like a chicken and an egg thing.
And you also don't know what confidential agreements are already put in place, especially by state governments in regards to feed-in tariffs, to actually really have a good understanding of the market you're actually competing in, and the advantages that may already be in place for a lot of these renewable entities.
Yeah, I mean, I do hear that there's a lot of the amount of renewables is kind of is somewhat scaling back in some areas, just because the amount of subsidies are going down, and also there's no assurances that they'll be able to build the grid out to actually take the power from those places either. So you got kind of stranded asset situations as well.
Just continue talking about power. Although the reactor itself is just a replacement for the furnace, to get the electricity, you still got to drive steam out to a turbine to produce the electricity. So in proportion to the size of the new modular reactors, how big does, how much additional plant have to hook onto that to get the electricity? Like, you're still going to be driving turbines. Will you be driving, I think the standard big turbine is about 600 odd megawatts.
Yeah, so I think a lot of the SMRs, well, the near-term SMRs, which are pressurized water reactor based, they're going to be using a lot of commercial off-the-shelf turbines of the 50 to 100 megawatt kind of output variety, because no one needs to reinvent the wheel, right? I mean, if you've got a vendor which has already got a proven and deployed design, you're just going to go with that, and that's fine. That's smart to do that. But of course, like in the future, it's not simply about steam turbines either, because the advanced reactors, as I say, they operate at a much higher temperature, and so you can actually then contemplate using much more efficient forms of power plant I mean, balance of plant kind of generation, such as Brayton cycle turbine, or what they call a gas cycle turbine, rather than a steam turbine, where you have to recondense the steam and everything else, which are much larger in
What
size
you
as
got to
well.
do is heat up gas to a volume so it provides the force to spin the turbine, is it? Or
Yeah, you can really miniaturize those, what they call supercritical Brayton cycle turbines. But
so
yeah, it's under
they'd be
development as
similar.
well.
So they'd react a bit like a gas turbine in regards to startup time and wind down time.
Yeah, I would say so as well. But of course, you know, with the supercritical CO2 Brayton cycle turbines, they are still under research and development, but they are, you know, there are a lot of companies looking into that, and yeah, I've been in chats with some of them.
With the modular and the egg carton concept, I would expect that scale of operation, you would sort of have the normal type substation we're familiar with, where the power comes out of the generating plant into a substation and sort of runs off a grid at 660,000 volts for the main line. That's our grid voltage. If people see those, if they're driving around and they see those great big towers and that, well, there's 660,000 volts. And then, of course, when they get towards the townships and suburbs, they're stepped down to, I think, about 220,000. And in our streets, it's actually 22,000 volts. And then they come into transformers down to 240 before they hit our home. So the egg carton type situation where you have got the equivalent power output of a large power station, would that be the same sort of concept?
Yeah, well, pretty much, because I mean, I've looked at the diagram of the layout of these SMR plants, and basically they've got like a transformer yard similar to you know, the large reactors as well.
For the, you might not know, but the small modules, if they're placed out along the grid to sort of provide that get over transmission loss, pick up the voltage, the supply when the other systems go down, and that, I'd expect they would have to have something similar, but it would be, if they go to connect to a major grid like a 660,000 volt grid, that would still take a substantial substation, and it would be more likely that those sort of things would probably be rather better connected into just to say a 22,000 volt system.
Oh yeah, naturally. I mean, the smart place of placing these things would be, you know, these industrial centers. So I think like Gladstone has a lot of like, industrial activity, for instance. I mean, don't you guys have an LNG export facility?
Yeah, it's big smelter.
Brownlow as well. Yeah. So I mean, a colleague of mine at Ansto as well, you know, used to be from Gladstone, big guy, and yeah, he talks about all the industry and the memories of Gladstone. Is over in Perth now. Yeah, so I would say that, yeah, you basically put it where you need the power, and then it strengthens the grid along those points.
So basically, you could have these in sort of industrial, like we have a thing now where the state government's involved in sort of promoting sort of industrial hubs or centres and that. So what it does is, say in Townsville, it talks to the local government and sort of looks at, well, let's create a industrial estate park or whatever, technology centre, and between the local government, state government, they might allocate a couple of hundred hectares of land for light industry and maybe manufacturing. And I think Townsville one at the moment is also talking about a hydrogen hub within that complex. So it has a reasonable amount of power usage. So, and the general feed for the overall area would be 22,000 volts. So you could have a modular within that just runs through that network, and then of course they have the small substations or transformers located.
Definitely. And those things, you know, those initiatives are great, and you know, the the whole idea is to get all the stakeholders together to come up with a plan that makes sense for everyone to invest in, you know. And it's interesting that you should touch on the hydrogen production as well, because I was just reading a scientific paper just looking at the different kind of options you have for producing hydrogen. Of course, you can just split methane and get that, or you can use some solar and use that electricity to push it through a membrane, which is another way. But in fact, you know, if you've got high temperature reactors, you can actually directly split water atoms to get hydrogen, right? And that's also extremely economic as well, like comparable and competitive against just very, very cheap wind, which does it intermittently. But of course, you know, with a nuclear power plant, you're doing it 95% of the time.
Well, with hydrogen, I think using natural gas, one of the biggest problems is you might produce hydrogen, but gee, you produce a lot of carbon dioxide anyway. So unless you've got a sequestration, it's counterproductive. And the other thing is when you go through the electrolysis method, which Twiggy Forrest is pushing down at Gladstone as well, and he wants to build all these tanks and that for the conversion. You're putting 100 megawatts into the process, but you only got to get 80 megawatts of hydrogen power out of it. Then you've got to compress it and ship it off somewhere to use. So all those things in train, you know, it just doesn't really make, to me, it doesn't make a lot of sense to go through all that, you know, losses and processes and that, and also building all those facilities, using resources to make that for something that's sort of, to my way of thinking, inefficient.
Oh, well, you're like some kind of project planner in the Air Force or something. You sound like you've kind of thought it all out. I mean, it's true. It's very true.
I'm an electronics technician by trade, but I was in the later years in the Defence Force. So I did work in projects and purchasing and
yeah. So you know the full extent of everything that's needed.
Yeah. So I look at the overall picture of anything, and it just befuddles me in regards to why you go to all this expenditure to get less out. But there's so many eager beaver politicians and promoters of these systems that it's hard to get any common sense or get people to do some realistic research in regards to what these things are actually worth and what they're actually taking. Like one of the worrying things about the one in Townsville, the hydrogen, it's a blue hydrogen, so they've got to use potable water to do the electrolysis, and it takes 9 litres of water to produce 1 kilogram of hydrogen. So the program is to send hydrogen to Kawasaki steel plants in Japan. So with every kilogram of hydrogen we send, we're effectively burning up 9 litres of water. And water is not something we want to basically give away too easily.
Well, you can always build a nuclear power plant to help you desalinate water, right?
Well, I put another process in the way, and let's make all these things. When all we have to do is build a dam and harvest it, and not waste it. So yeah. It's a matter of efficiencies for different things. But moving forward. Is there any other small innovations like in medicine or that are around the corner with nuclear energy? Because Lucas Heights has been basically a nuclear medicine, had a nuclear medicine function. Is there any sort of real growth potential and advancements in that area as well?
Yeah, I do hear of lots of advancements, but like more kind of targeted radiotherapy and heavy ion therapy, but I'm not the expert on those kind of like up and coming tech. I can actually advise, recommend some people to come onto your show to have a chat if you like.
Oh, that would be great.
Yeah.
But if you could now just talk, we know you're going to the States, and that's why we got you on this week before you head off. Although it might be off topic, do you want to give us a bit of a fill in about what you're doing when you go to the States?
Oh, okay. Yeah, no, so it's just got, there's a space conference happening over in Colorado, and, you know, as you might have heard, you know, space is a big deal for Australia currently. We're trying to innovate, we're trying to be part of the game there. But a lesser known kind of development as well around the world, it's this kind of like, we're going back to nuclear to have low carbon, but we're also going back to nuclear as a reliable source of power in space as well. So two of my kind of PhD students and friends of mine have a little startup called Uranos Systems. And that startup is embedded in the Innovation Center in Ansto itself called Nandin. And that little startup actually did a little project for the Australian Space Agency just to have a look at various different types of radioisotopes that could possibly be used on a space probe to keep the electronics warm and toasty. So to give you a bit of background, like everyone would have heard about, say, the Voyager space probe. I mean, it's gone past the boundary of the solar system, I believe. But to keep those electronics alive and functioning, I mean, those electronics were developed on Earth, you know, in a nice kind of room temperature. And so they will have to operate as well at a slightly elevated temperature and not at minus 270 degrees C, right? And so what happens is that you put these little electronic, you have these, say circuitry board, and you put a little piece of radioisotope there. It might be emitting something like 1 watt, not a lot, but you insulate it, right? And then so it keeps it warm and functioning. And so the project with this little startup Uranos was to have a look at, you know, whether we could create a radioisotope for that use and to manufacture it, you know, in Ansto itself. And that'll be a really cool story, you know, to build national capability. So yeah, and so the upcoming trip to Colorado is to look at, you know, what other people are doing, what kind of satellites they might be building, and what kind of power requirements they're looking at, and whether, you know, there are other companies as well that are also looking into nuclear power, because it's not something which is new. It's actually something that the US and the USSR, or the Soviet Union, were looking at. There were actually working reactors put into space, right, in orbit around the Earth, and it's under development that there are also plans to deploy miniaturized compact reactors to supply power on the surface on the moon as well as on Mars as well, because you can actually get more power for less weight in the form of a nuclear reactor than you can from very large kind of football fields of solar panels. I mean, to put it in context, the International Space Station that's whizzing around, right, with these football fields of like solar panels, peak power, I believe, is 125 kilowatts, right? So it sounds like a lot, but to keep, like, you know, 12 astronauts alive and to run everything else, it's kind of just adequate. Yeah. And,
well,
you know, yeah.
I think that's one of the things. A lot of people sort of, we're worried at the moment about global warming, but a lot of people just don't understand how just a small distance in altitude above the Earth starts dropping the temperature. And by the time where you get even though the International Space Station, you're down to about 273 degrees Kelvin, or almost absolute zero. So,
oh yeah, it's a harsh environment.
So I think people that probably don't have this perception of how cold it is out there and exactly what requirements you do need for survival. It must have, like the space station itself, it must have the functionality designed to keep humans alive. Just that functionality must have take up a large proportion of the whole system before you get down to the nitty-gritty of experiments and things like that.
Oh yeah, but I mean, it's extremely exciting as well, right? I mean, it's a very hostile environment, It doesn't matter if you're in a submarine, that's a hostile environment, you know, you're underneath 300 meters of water or whatever it is, at whatever pressure it is, or you're in space and you've got like huge doses of radiation coming in from solar flares and from cosmic rays. And so nuclear is actually a big deal, and a field of study for anything to do with space, either for radiation or for power or whatnot.
So with this conference, what sort of people and qualifications would they have, the general group that goes there, and how wide international group is it?
Yeah, so I believe that Colorado is like the second. Well, they're ranked second as being considered a hub of space kind of entrepreneurship or a tech hub for space, and that's why they're holding that conference there. And the reason why there is a contingent from Australia of space startups from Sydney and Adelaide and elsewhere going there as well, is to connect those startups and to have conversations with one another. And you know, for Australia, I don't know if you guys know, but you know, we're actually very, very strong with software engineering. And so like one of my friends called Jason Held, who's the CEO of Sabre Astronautics, they basically got the contract to put together mission control for the Australian Space Agency, right? And I've known Jason, and he's been working away at his code for like a decade and just perfecting it and increasing its capability until he actually had a product that actually worked. And you know, the Australian Space Agency was just going, wow, like this thing actually works. And now, I mean, Jason is dual citizenship. You know, he's both US and Australian. Now, you know, he's actually exporting that technology back to the US, where it came from. You know, it's a great success story. And so, you know, you've got lots and lots of very clever people that's going into space and space industry just because it's a huge growth industry. You know, the amount of market capitalization is just ever increasing.
Well, Australia has always been, or probably a lot of people don't realise, we've always been fairly innovative people. I mean, if
Yeah,
you
definitely.
go back into the 50s and that, you know, we're leading in computers. And I mean, our Woomer rocket range and our Jindovic and other things were pretty good for their time. So I suppose the thing that happened there is there was a general agreement that Britons were all in the science and we should just be the food ball. So that probably hurt us a little bit.
Yeah, but like I think our kind of like Aussie spirit is always there. Like we're always really, really you know, we're resourceful. We don't blow our own trumpets that hard, and we just get on with it, right? And that's, I think, definitely a strength of Australians, is that we just do more with less. You know, it's always been a harsh environment, and so we've kind of learned just to make do and to make things work. And you know, it's not even just about, you know, the history of Australian space, the Australian space industry, but also, you know, with our own, you know, research reactor, we built this Argentinian designed reactor, which we vetted and said, yes, this actually works. And we built it for like $500 million. And we talked to people overseas, like the equivalent national lab, say in the US, and they just couldn't believe it that we could actually build this whole thing and make it work for so little money, in their words, because we're actually just resourceful and just get it done.
And also, the money isn't so generously poured into you, so you have to make do on pretty reasonable budgets. But
yeah.
I think the other thing is too, and Eisenhower warned about it before in his farewell speech in 1961 when he left office. In regards to, he basically warned the United States in regards to get too caught up with this think tank mentality and having everything developed within these complexes and that, and foregoing the backyard and the garage tinkerers, that they'll miss out on a lot because of this mindset. And I think that probably has taken place in a lot of countries where everything's basically, if the government doesn't give you money, you don't bother doing it. So in Australia, well, the government might give you money, but they're not going to give you much. So you better you better produce something with next to nothing.
I think, but also it's a case where I think, you know, you can kind of call it revenge of the nerds, so to speak, because, you know, you get a couple of like clever people together and they're gonna like bounce off each other with ideas, and they're gonna work out something which is more clever and better than what's been done in the past. And I think, you know, for instance, what Elon Musk has done is really, you know, given the defense primes a run for their money. You know, they've managed to build this amazingly sophisticated rocket in the Falcon 9 and in Starship as well, and at a much quicker pace than any of the Boeing or Lockheed Martin or whatever. And so, like, it's a very, very dynamic and competitive state that the space industry is in.
Do you think also, in regards to the Australian psyche and that, because we don't have sort of people who sort of consider themselves elevated up here, that they make it difficult for minds to meet? It's just more, here's a group of people and they'll nut something out rather than depend on some person who's the figurehead type thing.
Yeah, I think that we've got this kind of healthy, this kind of feeling, or our kind of national psyche, the idea of like egalitarianism, right? The fair go, and, you know, I can relate to you, it doesn't matter, we don't really care about class backgrounds and whatnot. And I think that kind of horizontal outlook, horizontal management outlook, gets conversations going quite easily, gets people talking quite easily, right? But at the same time, you know, Australia doesn't have the kind of depth of industry that, say, the US has or other places. And so sometimes it's difficult to get clever ideas out of the lab and actually built, like made and built. So, but I think where, you know, currently there's lots of government incentives to try and help that out, or to encourage that, and that's a good thing. You know, I'm keeping tabs on a few high-tech developers. Like, for example, there's a satellite company called Space Machines that's operating out of Botany in Sydney, and they're going to be building what would be the largest satellite Australia has made, to ferry, or to basically behave like a space tug, to take small satellites and move them into different orbits, because these small CubeSats might not have the fuel by themselves to move around into the optimal orbits. You know, I think once we start building and creating these kind of tech hubs and gather even more tech startups to make more things, then we will have that solid kind of industry background created.
But I also think it would help if Australia re-industrialises. I mean, over the years, we've surrendered a lot of manufacturing and that to overseas. I think a return of just general manufacturing, a bigger steel industry, a bigger production of even things like aluminium smelters and that, they'll all lend volume to industry that allows innovators in other areas to prosper as well. Do you think that will be helpful, having, you know, a reinvigoration of manufacturing in general in Australia?
Yeah, I think definitely that is definitely the case. Australian manufacturing has been under a lot of global price pressures for a long time. For example, I chatted with Matt Howe, who's ex-CEO of Tomago Aluminium. They run this huge aluminium smelter near Newcastle in New South Wales. You know, and I think you basically need not only to support these industries, but to establish those massive kind of like nation building projects that require the steel and the aluminium and everything else, and to make it part of the deal that it has to be, you know, a percentage supplied from local sources, maybe, you know, not to just be completely like a dumping ground for other people's cheap steel and whatnot. But in any case, I think for the country, we are already addressing the issue of needing to maintain sovereign capability and to make sure that our domestic supply chains are strong, and that they're not overly kind of vulnerable to kind of global interruptions, supply chain interruptions and things.
Well, I suppose that's one thing about COVID. It really, and COVID and this last, say, 6 months with the problems with energy supply, petroleum and stuff like that, has really shown some of the kinks in regards to our supply chain, our resilience and self-reliance. And I would hope when they go to the federal election that a couple of these larger parties actually start talking about those things to make sure we put back resilience and self-reliance into our system going forward, rather than talking about more childcare allowance and things like that. I think we really have for too long been forgotten in regards to nation building projects, and it really needs to come back into the fore.
Yeah, look, I think families are suffering from the pressures of all around, casualization of labor and heavy industries being exported and things like that. So I'm no politician, but I know that there are a lot of pressing issues that need addressing, definitely. Yeah. Okay,
then we've just hit the hour mark. Mark. I got caught then. Is there anything you want to finish up on in regards to the nuclear industry and moving forward? And what do you think people in Australia and Australians should sort of look forward to in the future from the nuclear industry in regards to maybe lower prices and better electricity supplies?
Look, I think that sometimes when it comes to getting a new piece of tech, it's better to come second than it comes first, because you get the better tech, right? And so I would just say that there's lots under development globally, both for near-term small modular reactors and for advanced reactors as well. So I just encourage everyone to just look out for more information about nuclear science or nuclear reactors. You can Google Australian Nuclear Association, the webpage, and we've got lots and lots of kind of past slides and presentations that got lots of information about nuclear that people might want to have a look at if they're curious.
Well, there you have it, people. There's a website for you to go. We'll be putting it up along with this posting this video. I'd just like to wind up now and thank you for your participation and introduce next week's show. If you could just stay on the line and we'll have a short chat after the event. Thanks, Mark.
Thank you. Thanks for having me.
If you enjoyed tonight's show, please like, follow and subscribe to our Facebook page along with our YouTube page. Next week, joining me will be Professor Leslie Hughes. Leslie Hughes is the Dean of the Science Faculty at Macquarie University. She's also Director of the Climate Council Australia, and she was also a contributor to IPCC Assessment Report 4 and 5, and we'll be talking about the assessment process in this interview, and we'll be touching on when the IPC was founded, how the reports are constructed, who's involved in it, and what information is gleaned by the politicians and policymakers moving forward. So join us again next week. Thank you.